another equation up here. 2 sine squared x minus 5 sine x equals 1. Recognizing that's a quadratic in sine, first thing I want to do is subtract over that 1 and get it set equal to 0. So then I might try to factor. So I'm hoping there are two factors, binomials with 2 terms each, that will give me this left-hand side. If it's going to work, I'm going to need to have a 2 sine x and a sine x here. But I can see, in order to get a 1 here, I just have to have a 1 and a 1. So I'm going to get 2 sines and a sine. There's no way they're going to add to a 5. Okay? Or subtract to a 5. There's no way they're going to combine to give me a 5. I'd actually be subtracting them because they'd be opposite in sign. So that's not going to work. So this doesn't factor. So now we got to think back to algebra. What do we do when we have a quadratic equation and it doesn't factor? And the answer is we use the quadratic formula. So let me remind you of what that is. The quadratic formula says if ax squared plus bx plus c equals 0, okay, it's going to be a formula for what x is. It's the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Now, that's something that probably you've had memorized at some point in the past. It's entirely possible that it's no longer memorized, so you're going to have to remind yourself of it. Okay? There are a bunch of mnemonic devices for remembering how it works. Okay? I'm just going to tell you one story. Okay? The bad boy was feeling wishy-washy about going to the radical party because he was square. So he missed the 4 awesome cheerleaders. But that's okay, because it was all over by 2 a.m. Super corny story. For some people, it helps them to remember the formula. I actually need to look at the formula to remind me of what the story is. But looking at the formula, I can remember the story. Okay, so this is something you're going to want to know. And I would suggest every time you use it that you just write it out. And that we also, once we've determined that factoring is no good here, that we also explicitly just write out, my a here is 2. That's the coefficient in front of the squared term. My b is negative 5. That's the coefficient in front of the non-squared term, but that still has a variable in it. And my c is negative 1. Really important to remember that the negative sign is considered part of those numbers. Now, when what I was squaring was x, the quadratic formula allows me to solve for x. When what we're squaring is sine of x, what we're going to get is that sine of x is going to be the quantity we get from the quadratic formula. So it's going to be the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. The process of my writing it down and saying it out loud is going to make it easier for me to remember. Okay, so now I'm just plugging in these numbers. So if b was negative 5, the opposite of b is positive 5, plus or minus, we'll have the square root of negative 5 squared is positive 25. When you square a negative, it becomes positive. Minus 4 times 2 times negative 1. All divided by 2 times a is 2 times 2 is going to be 4. So that's 5 plus or minus the square root of, this is going to become positive 8. 25 plus 8 is 33, all over 4. I'm sorry, I said 33 and I wrote 38. I meant 33. So this is what we're going to have. Now, anytime you use the quadratic formula, double check. If the number under the root is negative, that's actually great, because that means there's no solution and you're done. You write the words no solution, nothing else to do. If it's positive, then we've got to check. Now, what I'm going to do here is I'm going to just distribute. This would become 5/4 plus or minus root 33 over 4. because I need to see. This is supposed to be what sine of x is. But I know sine of x can only take on values between -1 and 1. And sometimes when I have a quadratic and I use the quadratic formula, one or both of those numbers is outside of that range. That would also mean that's not a valid answer. So notice 5/4 is already bigger than 1. If I add something positive to it, no way. That's going to make it even bigger than 1. That's not going to work. So then I'm hoping that 5/4 minus root 33/4 is actually between 1 and -1. Now, if I'm doing the homework or a quiz, or if I'm on the calculator part of an exam, I could just plug into a calculator to check. But this could show up on the non-calculator part of the exam, and here's how I would check. I know that 5 squared is 25, and 6 squared is 36. Root 33 squared is going to be 33. It's in the middle. So this is between 5 and 6. So if this were 5/4, 5/4 minus 5/4 would be 0. If this were 6, 5/4 minus 6/4 would be -1/4. So this number is between 0 and -1/4. That's an acceptable value for sine to take on. So what we're getting is that the only viable answer here is that sine of x is 5/4 minus root 33 over 4. And in double checking to make sure that that was going to be in between -1 and 1, we also determined that that was going to be a negative number. Okay, because this is bigger than 5/4, so the negative part is bigger. Okay, so now I need to find my solutions. So I'm going to think, what quadrants is sine going to be negative in? Okay. Well, not quadrant 1, not quadrant 2, but sine would be negative here in quadrant 3 and here in quadrant 4. Okay. So I'm going to have a value of x in both of those quadrants, and then alpha is going to be my reference angle. Now, what I know about alpha is that sine of alpha is the absolute value of 5/4 minus root 33 over 4. And remember, we said that that was a negative number. Well, when I take the absolute value of a negative number, I just take the opposite of that number, right? Absolute value of -3 is 3. Absolute value of -7 is the opposite of -7 is 7. So I'm going to get the opposite of 5/4 minus root 33 over 4. And what that's going to do is that's going to make the 5/4 negative and the root 33 over 4 positive. Okay. So my alpha is going to be arcsine of root 33, I'm going to go back to just writing it as one fraction, root 33 minus 5 over 4. So here, this x is, that x is pi plus alpha, so that's pi plus arcsine of root 33 minus 5 over 4. This would be x equals 2 pi minus alpha, so that's 2 pi minus arcsine of root 33 minus 5 over 4. Okay. And even if this is on a calculator section of the exam, I'm likely to ask for exact answers. Remember, only plug into a calculator and give me a rounded answer if I explicitly ask you to round. Okay. All right, so my solutions between 0 and 2 pi are pi plus arcsine of this lovely mess, root 33 minus 5 over 4, and 2 pi minus arcsine of root 33 minus 5 over 4. all solutions, I'm just going to add a multiple of 2 pi to each of those. So I will get pi plus arcsine of root 33 minus 5 over 4 plus 2 pi n, and then 2 pi minus arcsine of root 33 minus 5 over 4 plus 2 pi n. And again, if I want to, I don't need to write that 2 pi. I can let that get absorbed into the 2 pi n. I do need to state that n is an integer. Okay. So you can expect the answers to be a little bit messy if you have to use the quadratic formula. That's okay, because you don't have to do anything with that messy number. You just have to, all we had to do was know whether it was positive or negative so that we could take its absolute value. Okay. So I'm going to give you another one for you folks to try to work on. Okay. And I'm going to suggest that you try this on your own and then tune into the next video, and we'll go over it together in the next video. Okay. So I'm looking at negative 2 tangent squared x equals 4 tangent of x minus 5. Okay. Now, one thing that's nice about that is with tangent, the range of tangent is all real numbers from negative infinity to infinity. So I'm not going to have to do the work we had to do in this one of checking to see whether my numbers are between negative 1 and 1. With sine and cosine, they can only take on values between negative 1 and 1. Secant and cosecant, I would have to check that their values are 1 and bigger or negative 1 and smaller. Tangent and cotangent, they can be anything. So it's kind of nice. Whatever I get is a valid answer that I just need to work with.